Okay, I apologize for the last video. After checking that out, it's obviously really skewed to the upper left-hand corner, and I don't know why. So I restarted my computer. And this is the last thing that we're doing today. We are going to classify the types of numbers, the sets of numbers, and go a little bit into number theory. So the first set of numbers that you need to know, or you can classify, are your natural numbers. And the natural numbers are simply, if you want to write down, I'll type. Um, the whole numbers. Actually, I shouldn't use the word whole numbers. That's a different. It is the numbers, the very first numbers you started counting on, like 1, 2, 3, 4, 5, 6, etc. So they, if you notice, that's exactly right, Lulu. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So Lucienne is 4, and she knows her natural or counting numbers. These are the things you can count on your hands and your feet, right? They are not decimals or fractions, not zero nor negative. Okay, so those are what we call the natural set of numbers. Those are the natural set of numbers. 1, 2, 3, 4, 5, 6, etc. All the way up to infinity, obviously. The whole numbers are the natural numbers and 0. So the only number that is a whole number but not part of the natural set is 0 itself. Okay? I forgot this little symbol that you can write for your natural numbers if you want to grab a pen and write. Anytime that you see this symbol, it's just an N, but it'll look like this with a reinforced bar down the middle. That refers to the natural numbers. Okay? The whole numbers are the natural numbers plus 0. Natural. So if I want to represent this as a number set, it'd be natural number plus 0. Okay? Let's go back to the beginning of the year. The very first unit was called integers and the order of operations. So if you remember, the very first thing that we started doing this year was adding, subtracting, multiplying, and dividing, and using exponents with positive and negative numbers. So the definition for whole numbers, or at least our working definition, is um, for integers is all whole numbers and their opposites. So opposites, put um, negative numbers in parentheses. And there is a fun symbol for the integer class of numbers too. A fun symbol for the integer class of numbers too. Let's actually get out the pen. And it looks like the natural numbers, except it's turned on its side and it ends up looking like a Z. So that means your integer, which is equal to, if I wanted to represent this algebraically, which would be all of the natural numbers are integers. 1 is an integer. 5 is an integer. 0 is also an integer, but also all the negative versions of the natural numbers, like -4, -5. Okay? So on to the crux of what we are talking about this unit, rational numbers, which we talked about a little bit as having something to do with fractions. The root word in rational is the first 5 letters, which is ratio. Any number that can be represented, and I'll highlight that, as a ratio of two numbers are considered rational. Any number that could be a fraction of two whole numbers or two integers is called a rational number. So I'm just going to use a working person's definition for what a rational number is. I'm just going to say any number that can be a fraction. Any number that can be a fraction. For example, 1/2. For example, 0.5. For example, you could even have a repeating decimal like 0.583 that we had in the last one, which was, I think, 7/12 or something like that, right? Any number that could be a fraction, you could have a top-heavy fraction like 11/4. Any number that could be a fraction is called rational. So if you think about what rational numbers are, the other set of numbers that real numbers are divided into are called irrational numbers. And the special thing about the irrational numbers is it's exactly the opposite of rational. Okay, so you think about what the word irrational means in, let's say, in the English class context would mean it's tough to deal with, tough to work with. So any number that cannot be a fraction would be irrational, part of your irrational numbers. For example, do we know any number that cannot be a fraction? Well, these include your decimals that go on forever but never repeat. Decimals that never end or repeat. Like, I think there's one on the board, or on our bulletin, on the border of our bulletin board. There is a very famous irrational number like pi. Pi is 3.14159. Dot, dot, dot. Keeps on going on forever and never repeats itself anywhere, nor does it ever stop. Okay? And the real numbers, all real numbers include all of these: irrational numbers, rational numbers, whole numbers, integer, any number that can actually be written as a decimal in any way, shape, or form. Any number represented by any decimal that can be written on our place value system, any decimal would be a real number. So let's check out the concept maps for all of these number classifications. I'm going to start with the most generic, and I think you know what that's going to be. The most generic classification is all real numbers. Real numbers are split into two broad categories. Real numbers. And if you want to write the symbol for real numbers, sorry, I fell off my symbol game there for a second, would be this R with the reinforced bar down the middle there, is your symbol for, anytime that you see that symbol, it means any real number. It's part of the real number set. So the first, over to the right here, would be your irrational numbers. And let's actually put some examples of irrational numbers. We already used the example of pi. Okay, pi is an irrational number, but pi is also a real number. It is the ratio of a circle's circumference to its diameter. It's a real value that can be calculated. It can be represented with a decimal. 3.1415 dot, 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 dot. Okay, also let's say like the square root of 2 is an irrational number, 1.4 something. It has a decimal that never stops. The square root of 13. For example, any number that is not a perfect square and you find its square root are called irrational. They're going to have decimals that can never repeat and they never ever stop. Therefore, they cannot be represented as a fraction, cannot be represented as a ratio. The other broad category of real numbers is your rational numbers. These ones can be represented. Rational can be represented as a fraction. So for example, let's put like 3/5 as an example on the outside of this box. Should be an example of a rational number, 3/5. How about 2/3? How about some decimals that stop? Like 0.82 is a rational number. I can represent that as 80/100, the ratio between 82 and 100. How about -5/8? How about the repeating decimal 0.333 on, which hopefully some of you guys know, is the fraction 1/3. Okay, those are all rational numbers. They can be represented by a fraction. Let's go and move into the next number category, which would be integers. Integers are rational as well. If you notice, the integer oval is inside the rational number box. So integers will include any positive or negative numbers without fraction or decimal parts. Okay, without fraction or decimal parts. So for example, like -5, -8, -16. Okay, those would all be examples of integers. But let's consider -8. Look where -8 is sitting on the concept map. -8 is an integer in its most specific classification. All integers are rational. -8 could be represented by a ratio of -8/1. All rational numbers are real. So -8 would be an integer, rational, and real. Let's move into a more specific class. The whole numbers. And there's only one whole number that is not natural, and the only whole number that is not natural is 0. 0, though, is a whole number. It is also an integer. All whole numbers are integers. All integers are rational. 0 could be represented as a ratio of 0 over anything. And all rational numbers are real. And finally, the most specific classification are your natural numbers. So inside your natural numbers oval, let's put it the numbers like 1, 2, 5, 2003. Okay, that kind of thing. Let's consider the number 2. 2 is a natural number. I can count it on my fingers. 2 is also a whole number. 2 is also an integer because all whole numbers are integers. All integers are rational. 2 can be represented by a fraction. And all rational numbers are real. So for the last part of your homework, which is 4.11 in the workbook, let that decide, okay, this real numbers diagram, this concept organizer, concept map, let that decide which sets a number is a part of. Hopefully that helps, and I'll see you guys when I return.